Hi all, this is Nizar, co-founder of Sitecore User Group Chennai. Today we have the session on Sitecore on Azure from IaaS to PaaS. It's a privilege to have Rob doing the honors with the session today. He's an MVP and CTO and wonderful gentleman promoting Sitecore across different user groups. Over to you, Rob. Thanks a lot for joining and please do the honors.
Thank you very much. Thank you for the opportunity. And welcome to this webinar about stepping from IaaS to a PaaS architecture on Azure. My name is Rob Habraken, and I'm both a CTO and Sitecore consultant at WeAreYou. WeAreYou is a big Dutch internet agency, but we also have offices abroad. For example, one in Bulgaria and also one in Melbourne. So we're quite well spread out. We do have a lot of expertise on both Sitecore and Azure, and I want to show you something about some things about how we adopted our DevOps process to the new Azure platform, which is not exactly new for everyone. So I kind of targeted this talk towards people that are quite new to the platform as a service stack. So if you're already on Azure, but you're only using virtual machines, then this talk is for you. If you're quite familiar with ARM, deploying a PaaS with PowerShell automation, Azure DevOps and stuff, then you might not see much new things. So, but please, if you see anything that is maybe not clear or maybe not relevant, then please let me know, and I will try to adopt my my talk. So I will not go over a lot of default Azure stuff because it's quite common knowledge, but a few things that are especially easy for us as developers and as agency is that Azure makes infrastructure and hosting part of the development team. And of course, you have benefits of a high uptime and easier resource managers in terms of pay as you go, but the real benefit lies in the scalability and the speed that you can alter your platform and also configure it from code. There's a lot of services. Today, I will purely focus on platform as a service. I have other talks in the future and in the past about things like functions as a service or Azure machine learning. The thing that you need to know is that there's a lot to discover, but also you can grasp everything at once. So we'll focus on the platform services. That's what we see in the center. Azure has a lot of data centers. We have experience with using geo redundancy over multiple regions. And the global coverage keeps expanding. One thing I want to tell you about this is that before you roll out in a certain region, you need to check what is supported and what is used by Sitecore. Some regions are still not fully rolled out, or not all functions are general available, and that's something you need to take care of. But I think in your region, all of the India regions are quite well equipped, and as I expect, exactly the same as the ones that we use over in Europe. The benefits of going PaaS from IaaS is that, you move away from the hardware and operating system one step further. So you're only focusing on your own application and your own data. And I think this graph on the left explains it quite well. You don't have to focus, or you don't have to do any maintenance on your middleware, on your operating system or whatsoever. So the only thing of your concern is your own application and your own data. And that goes for SQL Server. You only need to take care of your own database, not your database server. And that goes for your application. You should see it as, or compare it to, like only managing IaaS and not the whole server around it. But there's more in terms of scalability. So why would you choose a web app? Because web apps is the offering that we mean when we talk about PaaS, which is platform as a service. Well, the reason why you should choose web apps is because they're very easy to spin up and also quite fast in doing that. And you isolate your application layer from the service, which brings another abstraction. But also because you can, like, and I can explain that in different ways, but as it's written down right here, your complete infrastructure becomes part of your code repository. You kind of document everything that's in there, which been referred to as infrastructure as code, oftenly. And that means that your DevOps team, as a developer or as a system engineer or DevOps engineer, that's depends on the roles you have in your team, you become owner of how everything is provisioned. And you can create boilerplate from that, you reuse that, but also very easily do disaster recovery, rolling out new environments and stuff. For example, for one customer, we had a test, an acceptance, and a production environment. So there's 4 environments. And then they wanted to experiment a bit and have a kind of a sandbox environment. That's a copy of what they already have, but they just want to try things out and then throw it away. So we just used all the same scripts for rolling out the complete infrastructure of the acceptance environment, renamed it to sandbox, and provisioned and deployed everything. And within 1 hour, we had a complete duplicate of the environment. They did some things for like a week or 2, and then we could throw it all away and apply the learnings to the other. So you get way more flexible in how you provision and how you use your infrastructure. So that's kind of the baseline. Your deployment gets easier, your scalability, and thus your productivity. I'm not sure how familiar you are with Azure App Service, which is the layer on above the web apps. If you take a look at the app service or app services, you see multiple services or resources. You have Azure Functions, you have API apps. There's just different offerings, but the one we focus on is web apps. And as I said, you can compare it with IaaS. That's what it looks like or what it feels like. You don't get the same control, you don't get the same configuration, but that's your scope. An app service is built up in different layers. You have your Azure subscription, then within the subscription you pick a region, and within that region you create resource groups. We often create groups per environment, like acceptance or production or test, but you can do more resources or less. I would certainly advise you to use a lot of separation, because extra resource groups do not actually. Yeah.
Rob, sorry to interrupt you. We are not able to clearly hear you, so a little bit noise. So can you please adjust the mic and start?
Okay. I don't really have much to configure it regarding the mic. I can turn off the webcam. Maybe that improves the sound. Does that make any difference for you?
Yeah, now I think it's a little bit better than the.
Okay. Do I need to talk a little bit slower? Is that one of the things you
It's fine.
would
I think
help?
now it's, yeah.
Okay, that's fine. Okay. So you have multiple resource groups, and within the resource group you have an app service plan. And it's important to understand this architecture for using resources later on and knowing how to scale. because when you get an app service, you actually get access to a pre-provisioned, like you can say, web server that runs IaaS, and it's already prepared for you. And the moment you deploy, it doesn't spin up at that very moment. It's already running, but it's being allocated to you, assigned to you. And what you can see here is that there's an SKU, which is the size of your service plan you pick. So the bigger SKU you pick, the more CPU and memory you get. And you can run one single web app over a certain SKU, but you can also scale up later on. And to see what happens is that you actually have multiple instances running, but they all refer, and it's multiple W3, WP processes, but they all refer to the same share, and that makes it easier to scale. Let me give you a better example on scaling. You can have multiple instances of a certain size as one. All those instances within one app service plan refer to the same folder, the same directory, the same file set of your application. And it's being like assigned or bound to your directory. And this is important to know because when you move from IaaS to PaaS, and this is very important, you can't have differences between your instances because they share the same files, and you can't do any writing to the file system. When you're going to try, I'm sure you will get it to work, but it doesn't really scale that well. So you don't want to do that, and that's one of the reasons that the cycle logging, which was in the past on your within your Sitecore installation on the server itself, is now abstracted away to application insights, which is part of the Azure offerings. And when you're going to scale this, you have multiple options of scaling. You can scale up, which means that your instances do get bigger, but you have the same amount of instances. And you just assign more CPU and more memory, which we've seen before in that matrix. You assign more resources to one single instance. That's scaling up. And you can scale out, so you can add an extra instance. And the funny thing is that because this shares the same files again, that when you scale out from 2 to 3, it's going almost immediately. The only thing you have is the startup time of your application on that instance. You can also, and that's one of the cool things, you can redistribute your app services across service plans. And you can configure auto-scaling. And auto-scaling is where you, based on metrics or based on a schedule, let Azure scale automatically. And for example, you could do it manually and say, I don't want one, I want 4 instances at this very moment, which is very handy when you're going to test something or when you know that you have a certain amount of load. But what's even better is the automatic scaling lets you scale the number of instances based on, for example, and there's multiple options, your CPU percentage. So you can say that you, in this example you see here in the slide, you have at least 3 instances, but at most 8. And Azure should try to keep the target range of your CPU below 80% load. And this is very cool because it allows you to run less servers than on your on-premise environment, on your IaaS, because you kind of focus on the lowest number of required instances, and you only scale up when required. which means that you probably end up with less cost. And this is one of the things that's very important. If you're going to move from IaaS to PaaS, you're probably going to pay more because a VM is a single resource that takes about a few $100 a month, and you can completely deploy Sitecore on one instance. But if you're going to use PaaS, and we'll see that in a bit, you're going to use way more resources that all take up their amount of cost. And if you total them and you use them exactly the same way if you did with IaaS, it's going to cost you more. This is one of the examples where you can make the difference, try to get an efficient use out of your PaaS setup. Scaling up is also very easy. You can just, in the interface, pick the amount of CPU and memory you want. There's some other features as well you should take a look at. For example, the SSL support is only available in certain tiers. And you just change it and you save it. No need to redeploy. Your app keeps running, and it only takes a few minutes to process the change. This could be easy when you manually want to scale up an instance. But what we used to do, and you will see that later on in the presentation, you will see that we configure this within our ARM templates, within our provisioning. So it is all documented and infrastructure as code. So how does the deployment work? How do you provision when you use those web apps? There's multiple resource and building blocks, and you have to kind of depends on what type of Sitecore installation you have. When you still have 8.2, which is, I see a lot nowadays still, then the right level block is MongoDB. But nowadays we tend to see a move back to Azure SQL again, which goes for all of our new implementations. So you have multiple building blocks. You have the application insights for health monitoring. It also is used to attach a debugger. It's also used to view the logs of your application and see what the health is of your code and your performance. You have Azure Search. Azure Search has its limitations. You can also use Solr, of course, but Azure installs Azure on Sitecore is default configured with Azure Search. Of course, you have your SQL databases. Your Redis cache is used for making your application scalable among multiple instances. And this is one of the other important things to consider when going from IaaS to PaaS. You also need to change your architecture if you're not fully stateless. So your code has to be stateless. You can't use you can't rely on the fact that a visit will land on the same resource each time someone visits your application, and that even goes within one session. So obviously Redis cache is used by Sitecore itself to maintain state between switching of instances, but you should also take care in making your own implementation, your own custom code built on top of Sitecore stateless. And this is one of the parts that you need to go through before you can move to PaaS, because if you want to benefit from the quick starts that Azure has on PaaS, if you want to benefit from slot swapping, which we will take a look at later on, you all need to have a fully stateless application. And on the top left, of course, the web apps. The deployment strategy is cut in 3 parts. Normally, you would just configure a VM manually and then install Sitecore on it and deploy over it each time. It's kind of the same with Azure PaaS, but you see different roles. You have the provisioning of your whole structure. you have the deployment from, let's say, Azure DevOps nowadays, and that only focuses on deploying, not on provisioning. And then you have the management of the hosting, which is also completely separated from the deployment process, and you can change one of those parts without touching the others. So you can change things like Geo application without redeploying your application, or you can redeploy your application without provisioning it again. And so it creates a layer of abstraction in all those different roles of application lifecycle management, which makes it more flexible and easier to maintain. Also, when you deploy and you use the ARM templates that Sitecore offers you, you will see that all the connectivity in between the nodes and the resources are set up automatically. This is a diagram of Sitecore 8 because Sitecore created this for us back then, and it's quite easy to follow. For Sitecore 9.2, there's way more different resources I can show you later on. So the diagram I like to use is still this one, which explains that you have multiple resources connecting to each other, and this is a kind of default setup you roll out at once when you run ARM. So how does that deployment process look like? Well, you can do it via the marketplace. Sitecore still offers that, and it's a kind of point and click. You don't have require any technical skills. You do need to bring your own license, of course, but it's also like more suitable for, as I see it. I don't know, people may think otherwise, may think differently about that, but as I see it, it's more like for demo stuff and for trying out Sitecore in Azure. If you really want to go for a well-organized DevOps environment, you need to roll it out via ARM and web deploy packages. Some technical skill is required for that, but you can move right away to infrastructure scope, which make the maintenance way better. If you deploy via ARM and web deploy packages, you can later deploy your own customizations over top, which is actually your own Sitecore implementation. ARM templates is something of Azure, not of Sitecore, and it stands for Azure Resource Manager. And it's just an Azure standard. It uses JSON and it describes your infrastructure. We will take a look at some ARM later on. Sitecore also offers it, so maybe many of you have already seen it. I'm not sure if you're already familiar with it, but it's like a starting point for from Sitecore for you to provision your own environment. In the past, like if maybe 2 years ago, I changed the Sitecore script immensely. I totally overhauled it to my own likings, but along the way, the starting point from Sitecore got better and better, and there's only a few things we add nowadays, and that's also why I stopped sharing my own version of it on my own GitHub repository, because the differences are so small. I think what you see here is that Sitecore adopted it to the usage within the community over the years. And one other thing that is important to understand is the web deploy packages. Sitecore uses Sitecore web deploy packages, or SCWDP, and it actually just contains the file folder of your Sitecore environment and Deckpack packages to install the databases. Well, some prerequisites for running ARM. You now have the Azure PowerShell commandlets, which are called AZ, and you can run Azure commands to install your ARM scripts with that. I'm not going over explaining how to get this to work. I expect that you will easily get past this. I see there's an old link from A2 in here. I have new links on the bottom of my presentation. I will share this presentation, and you can also see all the resources that I've used in the end. So via PowerShell, you can run your commandlets and do the same tasks as you do in the Azure portal. And what's important here is that we don't want to do any manual configuration in the Azure portal, because those things get lost and you don't know what happened. You want to automate everything. So the Azure portal should be only be used for like, well, bug fixing or finding incidents or finding irregularities in your setup. And it should only be used to try out new stuff, but you should eventually always end up with using ARM templates to provision everything. Here's some instructions on installing Azure commandlets for PowerShell. And when you have those, you're just going to inject your either Mongo or nowadays SQL connection strings into your ARM templates, your credentials, and you use the PowerShell script from Sitecore, and then you enter some configuration, and then run the PowerShell script. I will show you how this works. The thing is that I wanted to show you that there's really only a few steps involved. And if you go further, you obviously don't want to store any passwords and credentials within your scripts and within your code. So that is what we use Keyvault for. Keyvault is a resource by Azure that enables your scripts to retrieve credentials out of the vault without your developers being able to see them or to retrieve them. So they can work on the scripts, but don't see the actual values, which makes it very secure. So let me show you a few things. I kind of, well, in the past when I talked about this topic, I went through the complete setup of the ARM, how it's constructed and stuff. But I think that's not only quite tedious, but also not something that is very easy to do via a webinar. The only thing that I want to show you is that we've added some custom stuff in it, and the thing that comes to mind most is that we add staging slots. When you add a staging slot, you can deploy to, and you see that in this case, it's a Sitecore identity web app. There's obviously more roles like CM or CD or SI, and you can all treat them the same. What we do is we add a staging slot to it, and we change the script so that we deploy to the staging slot. We don't actually deploy right away to the production slot, and then we use slot swapping to go live in a blue-green scenario. I will show you via a diagram how that works later on. We have our folder with, and in this case, it's the test environment of one of our setups. It's just the default ARM and PowerShell that Sitecore provisioned. It contains all the scripts to set up the Xconnect, Azure Search, and the infrastructure of your whole environment. ARM tends to need some getting used to. I advise you to use Visual Studio Code for discovering them. It works quite easy because you can easily collapse things and see the structure and scroll to it. I really find it way easier than any other tool to edit the ARM templates, and you just go through them and you just look at what's being created. You can also, when you go to the Azure portal and you just add some stuff like resources, might be a database, might be some other infrastructural stuff like a subnet or something like that, then you can always generate, and I'm not sure if I can show it to you right now. No, let's skip that for a while. But you can quite easily export the template, and then you get the ARM, and from there on, you just alter the ARM, then run with PowerShell. You can run that script, and you can see if it provisions the same resources as that you have set up initially. Then alter the script again and work your way through it. As you can see over, let me show you here, we have a PowerShell script, and in this case it's for a gateway, but it could be everything. We have a script that uses the Azure Resource Manager resource group deployment, and it just retrieves the JSON script I've shown you and runs it on your Azure subscription in the portal. And this way you can quite easily, from your local machine using PowerShell, deploy your resources. Eventually, we're not going to do it this way. We want to use Azure DevOps. So what we do here is in Azure DevOps, we have a pipeline to build our application. That's not something I want to go over today, but this shows you that you have multiple build tasks to generate your code, and then you have the release. And this is some maybe more interesting stuff for today, is you can really break up the installation and provisioning of all the different tasks and run them simultaneously. So if you look at this diagram, you see in Azure DevOps, we have what we call Sitecore refresh is actually the provisioning of a clean vanilla Sitecore installation. If we run this, the whole staging slot that we've created and added to the Sitecore script gets wiped. So it's completely empty. It's just a default web app from Azure. And then we install a vanilla Sitecore installation on top of that. After that, we're going to deploy all the different roles. In this case, it's for tests, we use the single setup, so no CMCD splitting. We have our own web API, which is not a Sitecore role, but you can also add it into the process. We have Xconnect, which contains customizations for custom facets and custom tasks. And we have the identity server deployment. Those four, are run simultaneously. So they all deploy to the staging slot. And when the first three are ready, you can see that we swap the slots. And you can play around with this. We have multiple environments. In this case, they're all set up the same, but you see the amount of tasks gets bigger when we go to a more complex environment. There's just more roles and just more servers and services or resources. And what we can do is, as you can see here in this step, we just swap all the slots. So we're ready with deploying, and we can go live quite easily with just deploying. Let me check. If you take a look at the Sitecore refresh, then you see that we run the same templates as I've shown you, but not from PowerShell, but from a deploy Sitecore step. This is actually a custom built step that we've created. A colleague of mine built this, and it uses in the background, it uses the same PowerShell, but it makes it easier to configure. You can also use it. You can just look it up online. It's a VSTS extension, and I've created this, as you can see, together with a colleague of mine, which is Anton. And it's actually a Sitecore deployer for Azure. This comes in very handy when you're new to a PaaS deployment, because it takes you by the hand and lets you fill in all the stuff like the ARM template part, the parameters, what your resource group should be called, like to which data center you want to deploy. and more of this stuff. What's actually good to know is that I think I will show this later on too, but this is one of the particular interesting features of the Sitecore deployer. You want your SCWDPs, which are your Sitecore source files, you want them to be private, but you also want to Azure DevOps to be able to download them and install Sitecore for you on Azure. You can do that by protecting with the SAS, the security access signature. But if you do that, you have to create a SAS manually and renew it every once in a while. This feature generates SAS on the fly at runtime, and it lets the deployment script use that specific SAS, and it will expire after your deployment. So you have a very secure and maintenance-free way of exposing your SCWDPs, which are on a blob storage on your Azure environment. So this step really contains some valuable help in setting up your environment. So to move on, the basic steps that I've shown you. Let me start the presentation again. The basic steps that I've shown you is that you have the ARM templates from Sitecore. You can use PowerShell to start them and to provision your environment. You can change your ARM if you want, like I did. I added slots, so I can do slot swapping. And then you can set up your build and release pipeline in Azure DevOps, and you can trigger the ARM scripts. And if you want to have an easier way to do that, you can use a Sitecore deployer to do so. And that's basically all there is to it. And the whole structure of web apps, interconnectivity, databases and stuff is all being set up automatically. One other feature that's very handy is that you can attach a debugger to your web apps, and you can debug your production environment or your dev environment. Could be anything running in Azure. You can go through it and you can step through it. Attaching a debugger requires some steps, so I advise you to just Google that. It would be a bit boring to explain it in here, but I just want to point out that this feature is there, which makes it easier to find some issues in your environment. And one of the things I'm saying is one of the reasons for why I'm saying this is that in Azure, things tend to be different than on your development environment. For example, if you run your development environment, you're using either Lucene or you're using Solar in the newer versions, and in Azure, you're using Azure Search by default. There's some configuration difference in those, and it could be that your application runs fine locally, but not on Azure. And because, well, that was just one example, but because of those differences, it's very important to be able to run against Azure and see what your code does and how it behaves there. Some things to take into consideration is you can use georeplication. It's by default it's used for storage, so that's an easy setup. You can also use it for your web apps, but it's very complex. And our experience is that the uptime with the default web apps in one region is also already so high that you would likely never require it. We do have some data disaster recovery environments that we have like a duplicate setup that's configured completely the same as the initial ARM set, but going to a different region and utilizing the daily backup, for example. So that's one thing you can easily automate when your complete environment is infrastructure as code. You can switch out the different integrations. One of the things I already mentioned is that Azure Search has some limitations, so you can use solar instead, works quite well. You need to be, or you want to be, on the consumption-based licensing of Sitecore. Customers that still have the perpetual licensing could go to PaaS, and it works perfectly well, but you can't scale automatically, and that's what you actually want. And the consumption-based licensing of Sitecore enables you to scale out your front end without impact on your licensing. Staging slots, I've mentioned them. They don't count in your license model, but they do share the same resources in your service plan. So if you have a high traffic site that's requiring a lot of performance, be careful with deploying to a staging slot on busy times, because it kind of eats away from your resources from your production environment. As if that really is an issue, you just need to have separate app service plans, and you can use a gateway or like a varnish cache in front of it to switch between the different slots, which you mimic by using different service plans. There's some limitations in PaaS that you don't have in IaaS. The number of cores and the gigabytes of RAM are limited. One thing, we run quite well on 7 gigs, which isn't much for people coming from VMs. They think 7 gigs of RAM might be too low, but you should take in consideration that the memory usage of a web app is only that of your own application and not of the operation system around it. So if you have a VM that runs 14 gigs, that includes, with a VM, that includes the OS, for example. When you run a web app, it doesn't include the OS, only your IaaS website. So that's one thing to be very careful with, not to spend too much on the gigs there, because you don't really need it. Also, the new Sitecore 9 architecture or infrastructure is divided in a lot of different roles, and you have way more resources. So they could all of those resources could be quite low in terms of resources and performance, because they add up into one well-functioning application without having those large nodes as a VM needs. When you use Azure Search, there's 1,000 fields per index limit. So you should, I think there was a nice blog about it a while ago by Bas Leijten. I can share it afterwards if you want. You can steer which fields are indexed, and you should do that, because if you hit those 1,000 field limit, then you are going to miss content in your index, and that gives you some strange results. There's a 1 terabyte limit per database, but you will likely never hit it. At least that's my experience. That's the most important ones that I see. If that's one of your concerns, you can't use PaaS if you're going across those limits. As I already said, make sure your architecture is completely stateless, and be aware you can't install any additional software on a server. It's only running your Sitecore IaaS website. You can't access things like registry, and you share your disk among all of the app service plan instances. So if you scale out to like 5 instances, you have 5 exactly the same file systems. Well, it's one system, but referenced multiple times. If you've seen before that I mentioned slots and swapping slots, because we have a goal of being able to deploy continuously, and that's one thing we can do with the PaaS architecture. We can do blue-green quite easily. So what do we need on top of what I've shown you using the ARM templates? First of all, we need to be able to redeploy everything, but we don't want to overwrite our database. We don't want to disturb the live site, and we will be able to roll back. If we can do that, and we can do it in a repeatable process, we can fully automate our deployment and continuously deploy. And we have examples within our organization where we deploy like daily, and we do that just during the day, and it works flawlessly. So if you take the set from Sitecore, you should consider a few things. First of all, you should be able to redeploy your slots without overriding the database. But if you run the deployment, including the database with the within the SCWDP packages, the Sitecore web deploy packages, then you get a vanilla database over and over. So we need to find a solution for that. And also, you might have to add staging slots to your ARM. And I will share a link that shows an example of that. So what we're going to do, and this is a lot of text, but I will just guide you through it. And if you refer back to the slides later on, it still makes sense, I hope. You should first roll out your infrastructure, and then you deploy your vanilla Sitecore on top of it. And then you should, well, kind of repeatedly reprovision everything, but without a database. And that's where it becomes funky, because the standard scripts use the SCWDP, which includes a database, and there's actually no good explanation on how to acquire those web deploy packages. I will show you how we do that later on, but first go to a schema of how this process works, not in text, but in images. First, you provision the resources, and when you're ready, you get an empty Azure app service. So no Sitecore yet. You only have the infrastructure. This is something you only have to do once. You can repeat it. If you run this again, it will just override everything, but it's just the same. So the outcome will be the same again. Then we will, in the staging slot, deploy Sitecore with our default content, which is just vanilla again. Then we swap slots just to test the swapping and to make it repeatable, because every time we're going to deploy from now on, it will be in our staging slot again. So we wipe the slot, install a new vanilla Sitecore, and then deploy our own content from Visual Studio or Azure DevOps. Now, when we're ready, we can swap that. Oh, excuse me, I was too fast with my slides. We can swap that, and we have our own site live. This is a repeatable process. We can do that every time, and we can use the same ARM scripts and deployment every time. This overview is not made by me, but it's made together with Microsoft and Sitecore to discover what options we have to deploy through blue-green. And I only wanted to show you the complexity, because this also uses multiple databases. And what I showed you right here is that we only swap the web apps, the web roles, but we don't swap the database. And the reason why we don't do that is because we use Unicorn for that. You all know Unicorn probably, and Unicorn lets you quite easily sync your content. If you make your Unicorn sync backwards compatible, and the only thing you have to do for that is just like not deleting anything that's still being used. If you want to delete something, you do it in 2 stages. If you have template A and B and you're going to swap, you're deploying template B today. Your new code uses template B. And when everything is migrated and template A isn't used anymore, in the next deployment, maybe tomorrow, you can delete A. And if you never have changes that break your build or break your environment, you can just first sync Unicorn and then swap the slots, and it works flawlessly. We do that for multiple projects for a few years right now, and it never proved as wrong. And if you want to roll back, you just push the old Unicorn files, and then, which is actually still in your Azure DevOps build. So you just run the previous builds. It deploys the previous Unicorn set of files, syncs again, and you're back on your old database. So you can go back and forth. If you want to do really blue-green, you can have multiple web databases and connect your web apps to one database, and the slots, the staging slots, to another database, and then swap your connection strings. The downside of this is that your content editors will also be required to pause, because there's only one master, so there will be a content freeze, as you see on top here. And the other downside is, I think it's getting quite complex. And the third one is that you will probably also have a cold start, because you're constantly changing configuration, which is config files, and that restarts your IaaS, and you don't want that. In this setup, you just deploy your staging slot, make sure there's no configuration changes, unless you obviously need to, but in a normal deployment, we probably don't need it. And we can swap without having a second of downtime. And because our app is completely stateless, because we have slots that run next to each other, we can go live having the same visitor visit the website, and with between pages, he gets the new website. And that's I think very powerful in this architecture. I'm going to skip this step because I'm already quite advanced in my time, and it's just going through the different things that you will find in your ARM template. It's quite easy to go over that yourself. What is less obvious is how to strip the database from your Sitecore web deploy package when you want to deploy without hitting the database. As I said, we want a repeatable process. So after we have provisioned the vanilla Sitecore environment and we deployed our own implementation and our content editors are using our database, then we don't want to install vanilla databases anymore, but we do want to install vanilla web servers because we have a repeatable process. That's why we need to strip out the database or DACPack from the SCWDP. And for that, there is a trick to use MS deploy to deploy from one zip file to another zip file with some parameters, and that's DB full SQL and SQL and DB duck effects, and then skip them. The thing is that there's a lot of parameters. This is a joke, of course. The command would be very large, and you don't want to have it specific. I thought I muted that. You don't want it specific to, you want it to be specific to the environment, but you don't want to have different scripts. So what we did is we abstracted all the parameters out because they're in our ARM anyway, and we made a PowerShell command of that. This is the PowerShell script, and it's just an example. It's in my GitHub repository as well. But what it does, it takes your SCWDP, which you can customize or download a new one, inject all the required stuff like maybe IP security or license files, and then create a new database-less Sitecore web deployment package. I thought this was a very valuable find in getting a repeatable process. So I will share the slides, as I said, and the link to this script and the updated version, which is on my GitHub. I can show it to you here. I have some scripts. One of those is the stripdb script, and it's very simple, but it's very helpful at the same time. So now you can just re-provision your deployment and swap your slots after warming up your site, which means that you can deploy without any downtime. In your Azure, you can, in your Azure DevOps environment, and this is quite an old screenshot. I think I've shown it you over here as well. It's in your release pipeline. You can, okay, this is annoying. You can go to the tasks. And what we do here is we deploy to a slot or app service environment. We're using the slot in this case, and we're using to the slot that's not visible to the users. And then later on, we use the swap command in our Azure DevOps environments to switch to that environment. One thing about customizations to your SCWDPs is that you can use cargo payloads packages to customize the configurations in there. There's a nice article by Bas Leijten about this, but in our case, we decided not to use them because we want to have easy rollback and rolling forward and back towards our builds. And if you're going to customize your config files in the source files, the SCWDPs, then you create a dependency between your code and your storage, where your SCWDPs reside. So we don't want them to become version specific, and found a solution for that. What we do is we actually use, well, we used to do Gulpit. There are some new, I've recently seen some new stuff in the Sitecore community that you don't have to use Gulp anymore. But we still do this on our environments to transform the artifacts, like the configs, of course. So what we do is we build multiple artifacts. We have the DLLs, which is like the build of our implementation, and then we create transform sets for each role. Could be CM/CD, could be Xconnect, could be SI, anything. And then when we deploy in Azure DevOps, we just pick the right artifacts, and we always have the build, but then we only deploy the right set of configuration files. And this works well for us. Started out as being a temporary solution, but ended up in being quite stable and working very fine for us. So instead of the cargo payload packages, we use this. So we get to the last part containing the tips and tricks and pitfalls. Some things you need to take care of is not to publicly expose your SCWDPs. I already explained the SAS. I didn't really explain how to generate them. You could find this out yourself, but you also could use our Sitecore deployer, which arranges this for you. You only have to check the box private in your storage so that it's not public. You should add up IP security. I think within 1 month, I will blog about enhanced security and using application gateway. Then I will go into this topic even further, but be sure that not to expose all your test and acceptance environments. You can set this up using role-based configuration in Sitecore, of course. And the last one is that you need to store your stuff in Key Vault. The ARM templates already use this, and you can also see on my GitHub how we do that. So let's skip SAS. Oh, one more thing. One more thing, if you want to take a look at the file system of your web app, you can still do so. You can't like log in remotely as you can in a VM, but using Kudu, you can just browse the file system, make changes, of course, only lasting until your next deployment, but you can try some stuff out and you can PowerShell into your complete tree. And this is what we use to see if a transform went right, what happens if we change a certain configuration in our test environment, of course, not on production. And it's a very handy tip. You can do that via the portal, clicking on Kudu, or you can add this to the resource URL just before Azure Web Science.net. Further things, I think I will, also considering the time, refer to my blogs. I've written a number of blogs about slot swapping, IP whitelisting, about Azure search limitations, about the event queue, and they're all kind of more like advanced topics in fine-tuning your Azure PaaS deployment. Oh, okay, that went wrong. So to round up, you've seen that, well, I've talked about a lot of different topics, but the baseline is that you use scripts using infrastructure as code to deploy your environment. You start with the Sitecore scripts, use PowerShell. You can use our Sitecore deploy step in Azure DevOps, and make sure that you have a repeatable process, which you can all read in this slide deck. The repeatable process should consist out of steps taken in Azure DevOps, but also in preparing your SC-WDPs. I have explained all of this in multiple talks and multiple blog posts, which you can find in these links. There's stuff about scaling, there's stuff about event queue issue. When you have staging slots, you actually have multiple instances running simultaneously, which can get you issues with the event queue. I've talked about hot swapping, where what you can do to make sure you don't have any downtime after you swap. So you have like a hot swap. I also referred to my my GitHub in these scripts, where you can find some examples of this. I think right now it's best to use the Sitecore quick start templates, but you can also refer to my scripts. They're still 8.8 because what I explained for 9, they're so good that I moved back to the Sitecore defaults. And if you want to see more content, you can check out my blog at robhabraken.nl. Do you have any other questions?
Some in the chat, Rob, so you can answer those.
I see some chatting here. Okay, I get a question about which type of web apps between shared or ACE, or it's called Azure Service Environment, or sometimes people call it ACE. Well, we always use shared, and the reason for that is shared is way cheaper, and shared has the benefits of scaling. When you use ACE, you have the benefit of having full control over your network, over your subnet, over your IP whitelisting, over a lot of stuff you don't have when you use shared. For example, the ports that are open on your web server is completely controlled by Azure when you use shared. So when you have a penetration test from a security team, they will most likely point this out. If you want full control, and sometimes banks or other highly secure environments require the use of ACE, then you need to reprovision all your instances upfront. So you lose the benefit of scaling infinitely, and you also pay quite a bit more. But on the other hand, you get full control of your subnet. What we did to make shared environment more safe is add an Azure application gateway in front of it, and just configure our ciphers and stuff over there. And usually it tends to come out very, very secure, and we don't need to go ACE. So yeah. There's another question about how to install or manage the custom languages in the web app. Oh, that's a good one. So you mean that you used to install custom languages on a web server, and you now want to influence that on a web app? I honestly have no idea, because I never came across this question. We do run quite a lot of multiple language sites, but they're all in the European language, so that's not something we bumped into yet. So sorry, I can't answer that.
Okay, Ralph, thank you. And it was quite a good experience for us to see a lot of features you have deployed in DevOps, Azure DevOps. So I would like to have another session uh, which is focusing much on the Azure DevOps part. Okay.
Okay, I can do that. I think that I see this webinar as a broad overview of all the topics you touch when you go from IaaS to PaaS. And I don't think it was or is a good tutorial to understand the whole process fully. I really think I can talk an hour only on Azure DevOps and show how we configure that from scratch. So would be my pleasure to do that. Absolutely.
Thank you so much. And we have one more question related to Azure Search. Which one is recommended, like Azure Search or Solar Search?
Depends on your requirements, of course. Azure Search is a bit more limited in features, and I see people that use the indexes heavily. They tend to bump into issues with search, and they move to Solar. For just like the more basic Sitecore installation, Azure Search works fine, and we actually have like maybe up to 10 sites running live in production on Azure Search quite well, but they have a simple search functionality. If you have complex indexes, a lot of customization on your indexes, or if you have a search on the front end of the website that you need to influence from the using like filters and cross index searches and stuff, then I think you better go with Solar. You should see it as Azure Search is the default starting point. With for regular use, it would be just fine, and Solar is the more advanced solution.
Okay.
The upgrade process, I see a question about that. How is the upgrade process in PaaS from one version to another? Actually, you change out your SCWDPs, and you change out your ARM script that you download from Sitecore, and then you get a new provisioned environment that's completely updated, because the provisioning of the environment is not bound to your code in any way. So the process on your dev box on your own laptop of, as a developer, of upgrading your solution from 9 to 9x or 8 to 9 is just as it has been before. But basically, you can just set up a whole new environment with using different SCWDPs and different ARM templates. And that's how we do it as well. We just migrate locally, then spin up a new environment in the other version, I also see the bigger customers of us that have multiple Sitecore instances running. They just have multiple sets of scripts, and you just can say, we want a 9.0.2, and then they run that script, and you get it provisioned, and then you install your own installation on top of it. So you get more separation from version provisioning and your code.
Thank you.
Does
Rob.
that answer the question?
Yes, Rob.
Okay.
Thank
Cool.
you.
So, any other question, guys? So, I think no. So,
Okay.
thank you, Rob. So, on behalf of SU Chennai, I just want to take this opportunity to thank you, Rob, for this wonderful session. You talked about how to provision and deploy, and you also covered code walkthrough and deployment scenarios, plus tips and common pitfalls, etc. So, looking forward to have more session from you, Rob. So, thank you.
Okay. Thank you for the opportunity, and I will share the slides. Well, I think it's best via you, and then you can make them available for all the attendees. Okay.
Sure. Thanks, Rob. Please share.
Okay. Thank you very much, all.
Yeah, bye.
Thank you.
Bye bye.